good evening, everybody. Tornadoes yesterday and tons of rain in Texas and parts of the central U.S. today. Plenty of fun, but thankfully the damage was extremely isolated. Thanks for joining the Meteorology Lab channel. I'm Tim Vasquez, and for the next 20 minutes we'll be taking a look at weather around the country. It's been raining here for 15 hours continuously, so I don't have any time-lapse video today. It's a good way to get a ruined camera, but there's a few shots there for you, and this is the large-scale pattern. Let me get this all centered here. We're looking at the temperature anomaly on this map here, and you can see that the warm sector has developed into this wedge here. So this is all warm air coming up from the Gulf of Mexico. So this is a very easy way to look at what's happening outside. You can pretty much paint out the warm front like that, and cold front coming down through Texas. So even without looking at the surface chart, you can very easily distinguish the air mass contrast across that boundary. Great Basin area, lots of cold air on tap there, and that's affecting parts of the western U.S., so I'm going to show you that in a little bit too. And plenty of warm air up to the north, and you may be wondering what's causing that. Well, look at the westerly wind component here, coming right off the Canadian Rockies. So there it goes, flowing across that, and we've got adiabatic warming and downslope conditions, warming things up pretty good. What kind of temperatures did we have today? Let's take a look at that. Very drastic warm-up for Texas, 60s in the DFW area, and saw 70 degrees here earlier. We've been pretty steady here at a 55. That might have been earlier this morning when that happened. I think the rain has really cooled things down. Up to the north, pretty mild. Same thing out to the east. Temperatures near seasonal normals. And most of the unusually cold air, as we pointed out in the high deserts of the western U.S. So let's see what's driving the large-scale flow. We'll go up to 500 millibars. This is 18,000 feet, or 3 kilometers, 5 kilometers in the atmosphere. And you can see we're dominated by this zonal flow. We've seen that the past few days. And right there in the middle, large-scale trough over the central and west U.S. And then superimposed on that at an even smaller scale is this shortwave trough. And as you might guess, even drilling down further, probably small-scale impulse waves moving through there. So a whole bunch of different scales going on here. The main thing going on, long wave pattern out over the western, or out over the central Pacific, long wave ridge across the western U.S. So that's helping to keep things a little bit cool in the northeast U.S. The rest of the country, pretty much trending towards warmer than normal. Let's take a look at the frontal analysis. We can see a low pressure area right there in Illinois. And most of the banding of thickness lines goes from Baja California up through Texas and Missouri. So we're going to put the front pretty much like that along that line of precipitation. And we can kind of trace that all the way down to whatever cities are down here. I'm not too familiar with northwest Mexico, but yeah, that's where the front is, through there. And then through Indiana and Ohio, looks like a bit of a warm front there. And as you might guess, if we had a little bit more moisture, we could be primed for severe weather here, but I don't think that's the case today. Then up to the Pacific Northwest, we've got a new frontal system affecting the Washington coast here. You can see that coming on shore right there, and probably a piece of that coming down through Oregon. Looks like a tiny bit of banding there. So that's what we're going to look for on the surface charts. And let me get that started up. There's a whole lot of charts I have to keep up with to do this weathercast, and it's kind of a big scramble to get this all done. So let me pull down that data. I like to use this METAR here from College DuPage. Maybe I'll show you a little bit of that raw data that generates these maps. And while I'm at it, I'll get the synoptic data too. Okay, so we got 3 p.m. data coming down. And it is crunching the data, and pretty much done, so we'll plot that. This will give us a map of conditions across Texas. We can see northwesterly flow working into North Texas and West Texas even. And we've got still some rain down here southeast of Dallas where we're at, and leading edge of the front from about Little Rock through about Waco, maybe Austin, down to the Big Bend area, Texas. And you can see down to the south, pretty good moisture on tap. Lots of mid and upper 60s along the Gulf Coast. But closer to the warm front, I think we're going to have to go to the other map for that. Go to the central Mississippi River Valley, and you can see some 60s dew points coming up to the boot heel of Missouri here up to almost St. Louis. That's the better moisture, and it's not quite made it up to Illinois and Indiana proper. But it does look like the warm front is a little bit south of there, so probably a little bit like that, and then we pick up the cold front, maybe something like that right there. In center of the low pressure area, got a 095 plot there, so that's going to be right around Columbia, Missouri. So we're expecting conditions to kind of degrade a little bit in Indiana and Ohio as that system approaches, but still lots of warm air. So we're not looking for really any winter weather here. Okay, let me take a look at the chat here, and got almost 20 people on, which is definitely good. See, we got S. Kinney here, Krakatoa 67. That's a new person there mentioning ice storm in Portland. We'll try to take a look at that real quick. Alexi and Fred and Kevin and Jay, Jeff checking in, GeoNerd. That's also a new viewer here. Where's the music coming from? Good question. Fred, Sue, Kevin, thumbs up on the radar instruction. I've got a little bit of I've got some frames here from that tornado last night. I'm going to show that to you real quick. And, all right, very good. 37 in northern Indiana right now, dense fog advisory. And also in Indiana, 47 in rain. All right. I went ahead and pulled down the radar data from that Whitney storm. And you probably don't, some of you may not know where Whitney is. It's going to be in the North Texas area. Let me get this centered here. I don't have it quite set up here. Okay, so here's Texas. Fort Worth is here, Dallas is here, and Whitney is down in this area, just west of Waco. This was about 7 p.m., about actually 6:30 p.m. last night. And you can see these storms don't look particularly unusual. They look kind of just, like grungy showers. But you can see we do have a tornado warning on that. So they are tracking that. This is last night. They were tracking the storm. And this was the severe weather statement here, tornado warning. And they had a law enforcement confirmed tornado at the time. So let's see what that looked like on the storm relative velocity. And here, yeah, you can see some very strong velocities. We had 42 knots of outbound. And in this area right here, about 12 or 13 knots inbound, a little bit of circulation. And then I believe we saw that start tightening up. Right in this area. 028 right there. And you can see the outbound really pick up right here. So this purple in here, this was about 52 out, and the reflectivity was looking like this. So you can imagine back in the 70s and 80s looking at the storm when you didn't have velocity, this would look pretty nondescript. You probably would be maybe even sleeping through it. But the velocity definitely paints out a much different picture. So without the velocity data, back then they had to look at other indicators such as high echo tops. So you would look for a cell that had unusually high tops compared to the other cells around there. That would be one indicator. And in this case right here, we've got the cell topping out at about 47,000 feet. And then you would look at other patterns, kind of like you would see the swirl pattern. So that would be another indicator you would look at. And you can see on the velocity here, look at that coming together. The diameter of that circulation last night, this was at 0041, 6:41 p.m. Diameter on this was about 2.5 miles, but we were looking at 31 versus 63. This is probably about 100 knots a shear right here. So we had a very strong meso at the time. Now the problem with this particular storm, though, this was about 60 or 70 miles away from the radar, so you were overshooting a lot of the important tornadogenesis processes coming together underneath the storm. This is up at about 3,000 or 4,000 feet. So at this range, this can be very tricky for detecting the actual tornado on the ground. So this is where spotter reports really come in and can become critical in the warning process. You can see here that circulation really tightens up right there. So that's the storm last night, and I'll just show you a couple reflectivity images real quick from that. You can see it was very HP-ish. Okay, so that was a quick look at that, and we'll just go back to tonight's charts. Okay, let's check this out. I was looking at the Portland, Oregon area because there was some severe weather warnings, or some winter weather warnings it looked like. And let's see what they had. Freezing rain advisory. I don't think that was for there. I can't really tell what's going on here. This color scheme is a little bit confusing. There's lots of purples in here. And I know one of you is in Oregon, so maybe you can go into chat and kind of clarify what's going on. This is probably ice storm warning. Maybe that's what we're looking at here. Anyway, this is one of the problems I have doing the weather across the entire country. There's really so much to look at, and I'm not quite in tune with everything that's going on here. So let me just take a quick look up in Oregon and see what's going on there. Not seeing much on the surface chart here, just southerly winds, but we know that warm front is somewhere down in this area to the south of there. So there could be a little bit of an overrunning situation in that area. Elsewhere around the country, I went ahead and set up wind grids. Maybe we can take a look at that real quick and run a cross-section through the Great Plains. We haven't done this in a while, and this is a good way to learn dynamics. So we know that the cold front is down through western Arkansas to north Texas, and we should see kind of like a frontal surface across the Central Plains on that cross-section. So let's do that. We'll bring up wind grids, and we'll set up our cross-section. And before that we do that, we do need to load the data. So let's do that real quick. And this is built on a very old weather service program called PC Grids from the early 90s. And it's been kind of adapted to Windows. And this basically lets you look at all kinds of model data. And the cross-section stuff is very important because there's not too many websites. In fact, there's none I know of on the internet that let you do flexible cross-sections. So let's see, let's do that. Let's set up a cross-section from just off the Houston coast up to Nebraska. So you can see that cross-section get set up here. And these lines here, these are calibrated in latitude degrees. So this is 32, this is Dallas right here. 35 is Oklahoma City, and 3940 is Kansas. Okay, so let me put the product up. So we're looking at potential temperature lines here in brown. These are kind of like isotherms, except everything here is normalized to 1,000 millibars. So what we're seeing here, you know that fronts are on the warm side of a gradient. So you would, potential temperature surfaces, they actually warm as you go up higher and higher. So if we put that on the warm side of a gradient, we're going to put the frontal surface kind of like that. So that right there is the frontal surface itself. Above that is tropical air, and below that is polar air. So let me start that again. The program is a little bit finicky. I'll just rerun that. Okay. So the frontal surface for 18Z, 0Z. Okay. So that's going to be near the surface around Dallas, and then we can see it lift up to maybe 850 millibars and then get higher and higher to about 700 millibars over Kansas right there. And you can see where the surface is sloped, that's where we have the upper level jet in yellow. These are isotachs up here. And you can see that the tropopause is really not that much lower over Kansas and Nebraska. So there's the jet. And let's see how that changes over the next day or two. Let me get this centered. Okay, so now we're animating this in 6-hour time steps. And you can make out the boundary right here. This is the frontal surface and the upper level jet in yellow right here over the Dallas and Oklahoma area. And not much change really. The jet just kind of sits over the Dallas and Oklahoma City area. Then we see some of that shift well to the south towards the Gulf Coast. That could be the subtropical jet setting up in that area. So not a whole lot to look at, but I did think it kind of important to look at some of these cross-section tools, because when we have our next system come through, we can probably take a look at that and really pick it apart. So I think that'll bring us to our forecast. Let me get that set up here. Okay, so there we go. Let me take a look at the chat and get up to speed with that. Yeah, Fred said red is away, green is toward. That's right, green or blue can be towards the radar. Brian made the live show again. Fog lifted in the Van Buren area. Jay says, does low reflectivity mean less moisture in the area? I don't think it really corresponds to anything in the air mass. It's basically just where the showers are not occurring. As far as the low, in the storm, in the low reflectivity levels in the storm. Yeah, I see what you're saying. The intensities are not all that strong in the storm. That's probably a reflection of there being less hail within the storm and less instability. Because to really get the higher values, you need large droplets, a lot of wet hail falling in the storm. And there's not so much of that in this particular cell. It's basically just small garden variety rain shower drops making up the scatterers in that storm. The news reports on the Texas tornado said it was a EF1. That's what I saw right there. I'm not sure if they sent out any crews on that. Krakatoa says, ice storm in Portland should start on Tuesday, Wednesday. Okay, yeah, we'll check that out on the GFS here. Okay. Okay, let's move forward and check out our weather here. Here's our departing system coming out of the central U.S. Low pressure right there. Okay, so we're familiar with that. And then let's see what we have on our webcast for tomorrow, Tuesday. The system moves through the Great Lakes right here. And the trailing cold front makes very, very little progress into Tennessee, Mississippi, Louisiana, just more of a stationary front. And I don't know how many viewers we have in New England, but it does look like we get a little bit of warm front action here. Some fresh cold air coming from the Canadian Maritimes, and that's setting up some freezing rain and snow in New Hampshire and Vermont. High pressure out over the western U.S. underneath this plateau high. And we see some rain starting to come into the Portland and Washington area. And when we do Wednesday's webcast, looks like some more quiet weather, a few showers along that persistent stationary front boundary in East Texas and southern Arkansas. Mostly high pressure through this, broken up by this lee side trough. New system coming into Colorado and Oregon, and snow right there in the higher elevations. And you can see that the gradients are starting to increase coming on shore, so we're starting to get some winds moving into that area. As far as ice for Portland, Canadian model, or the GFS model, not really going for any of that, keeping everything pretty liquid. I can look at the Canadian model real quick to see what that shows. Granted, these are global models, so I don't have the mesoscale models set up. But yeah, Canadian model going for a little bit of freezing rain right there around Portland. And we're talking about Tuesday midday for that. Then that moves, looks like closer out to Pendleton for Wednesday. Okay, let's see here. For Thursday, things still remaining pretty quiet, just kind of a lee side trough remaining in place and warm air advection. Yeah, is that right? Yeah, that is warm air advection. Low pressure through here. Yeah, see, I was thinking maybe we had northerly flow. I was kind of mixed up on that, but yeah, it looks like we do have a southerly gradient starting to set up behind that front, probably lifting that front north. Upper level system coming through the Rockies right here. Then for Saturday, still pretty quiet in the central U.S., but we have this Pacific system on the way moving through Arizona, and that'll come out into the plains on Sunday. So for Sunday's webcast, we've got low pressure there in northern Arkansas. Surface fronts will be looking kind of like this. And you can see it's a pretty warm system here. Not really any snow or freezing rain associated with that, but there is some pretty stout cold air advection, so we're talking probably highs in the upper 30s and 40s through Texas and Oklahoma. Another system coming on the Pacific coast here. So that'll be working inland on Monday, and that'll reach Texas sometime on Tuesday. So our fronts will be looking sort of like that. And that'll move northwestward on Wednesday, and just a few showers along that cold front right there. And it looks like things get kind of quiet, and we started vecting down some colder air. You can see that 540 line starting to come southward during the middle and end of next week. So things should cool down quite a bit if that pans out. And it looks like with that cool air in place and looks like a Pacific system starting to move inland, we're starting to get a little bit of isentropic lift developing along the edge there. So GFS going for some wintry precipitation all the way from Del Rio all the way down to Laredo. That's interesting. but we are about 360 hours out. So look at that, pretty good blob of cold air across the southern U.S. and very warm up north. It's a very unusual configuration there. Let's see what the Canadian model has got real quick. Going pretty much with the same pattern of Pacific systems moving across the south. 21st, 22nd. Then 23rd on Monday. Looks like a Gulf Coast system well to the south and bringing cold air down into the Texas area. So, yeah, these systems are quite a ways off. This is like 5 to 10 days, so I'm not going to worry too much about these right now. We'll probably see the forecast on those change quite a bit. But it does look like it's finally going to get colder, even the Canadian model, bringing that 540 line down through Texas and Oklahoma. So we should start to see a slow change to the pattern over the next week or two. And we've got quite a few people on here. We're up to almost 30 viewers. That's great news. I appreciate all the activity here. And let me take a quick look at chat. Krakatoa is in Manchester, New Hampshire. Looks like 2 to 4 inches of snow there, late Tuesday into Wednesday. Good deal. 1 to 4 inches of snow in Denver. Hopefully that's not causing too many problems. And Fred celebrating the 552 decameter line over the Dakotas. And I think he was talking about this here. Look at all that warm air. Well up to the north, Fred is up here in the Grand Forks area. So it's very strong downslope flow. That'll probably warm things up in that area. Let's take a quick look at what the temperature is forecast there to be. Let me see if I can bring up that frame real quick. Uh, 35, 22, yeah, I guess we're talking about last couple of days of January bringing some 30s and possibly 40s here to the Rapid City area. And that's probably warm by their standard and measure there. Anyway, I think that's about all I've got for today. That's just a quick look at the forecast, and I would like to ask you all, please comment and like and subscribe if you're looking at the archive of this show. I definitely appreciate that. I don't know if you can like the live broadcast or not. I'd have to check that out. But in any case, whatever you can do is appreciated. Hopefully we'll see you all tomorrow at the same time, 8 o'clock, and have a good evening, guys. Thanks.